My machine is a Mac, so you'll notice that the user interface looks a little different if you are modeling with another operating system, such as Windows or Linux. From the tutorials, open the Viewing Microsimulation Outputs initial network. Here we have a small model of the area surrounding the famous Camp Nou. In the project window, under Scenarios, there are two scenarios already prepared, one for the base and one for the priority. Let's first run replication base by right-clicking and selecting Run Animated Simulation. In the control box on top, press play. The bar on the left allows you to control the speed of the simulation, while the bar on the right allows you to control the smoothness of the simulation. Let the simulation run for at least 10 minutes of simulated time, or use fast forward, then hit pause. The eye icon in the control box shows the real-time information about the simulation in the Output Summary tab. You have the total number of vehicles waiting to enter the model, currently inside the model, have reached their destination outside the model, currently lost inside, and lost outside. That information is also available by vehicle type. Before we proceed, let's set the view mode back to none, and we will get back to this feature later. For now, we want to look at the statistics and time series of individual vehicles. Double-click on any vehicle to open. In the Static Attributes tab, you can find information such as the vehicle type, its origin, and its destination. In the Dynamic Attributes tab, you can find its current speed and position. If you click on Follow, it will center the vehicle in view and follow along as it moves through the network while the simulation is playing. Note that you have to keep this window open in order to use the Follow tool. In the Path tab, you can look at the next sections in the vehicle's paths or display its current path and highlight all the sections from its origin to its destination. If you go back to the Dynamic Attributes tab, you can activate the collection of time series data for the vehicle. You'll notice that a new tab called Time Series appears. In here, let's display the variable speed. And while the simulation is running, you can track the movement of the vehicle and its speed at every simulation step. Now we'll have a look at time series and objects. In the project window, open Dynamic Scenario Base and go to the Outputs to Generate tab. Here we can set the statistics and detection interval to save every 10 minutes. This means that data will be recorded for sections, turns, and other objects in the model every 10 minutes of simulated time. Click OK, and let's run replication base all the way to the end. Once the simulation finishes, click OK to close the pop-up window, and using the magnifier tool, zoom into this area with the detectors. Double-click on the detector to open and select the Time Series tab. Let's go to Variables and display the count for last generated, which refers to the simulation we just ran. Go back to Graph mode, and you'll see that the data points appear every 10 minutes, and in Table mode, the counts are shown every 10 minutes. You can display multiple time series by clicking on the plus sign, back in Variables. Let's keep looking at the count for last generated, but this time set the vehicle types to car and truck. Now, we can see the number of cars and trucks that pass through the detector every 10 minutes from 8 o'clock to 9 o'clock. This type of time series visualization can be done for any network object. Let's close the detector and then double-click on this section to open. In the Time Series tab, you can browse through the different variables in alphabetical order. You can display it in a graph and display the mean or the deviation where available. Additionally, different variables can also be displayed simultaneously. For example, let's go back to variables and display the density, plus sign, and the flow. So if we go back to the graph, we can see the density and the flow plotted in the same graph. It's also possible to show the time series of multiple objects in the same graph, such as the approaches of an intersection. Let's look at the approaches of node 2062, and you can use the search bar on the top right corner to look for the intersection and then zoom in. Now, let's go to Data Analysis and open the Time Series Viewer. While the window is open, select the approaches of the intersection. You will see that it's counting 3 sections and that the sections have turned red once they are selected. Now let's look at the delay time from replication base for all vehicle types. Click on Add Series to display the values. The scale can be modified by going to Actions, Auto Scale. The data can also be displayed as a chart instead. Here, we see the delay time at 9 o'clock, or we can change the time using the forward and the back arrows. The play button will automatically show the change in delay time from the beginning to the end of the simulation. The aggregated values can also be shown by clicking on the letter A. This type of time series analysis is not limited to graphical objects. It can also be used to compare travel times of transit lines or delay time of subpaths between base and future scenarios, to name some examples. Now let's look at view modes and view styles. In the Aimsun Next template, in the project window under Data Analysis, there are view modes and view styles already created. These are very useful in different stages of a project, from doing visual checks of parameters, during calibration, or looking at the results during and after the simulation. If you ever lose them, don't worry. You can always regenerate them by right-clicking on View Modes and then clicking on Generate Default View Modes. Let's activate the legend window from Window, Windows, Legend. Let's snap this window with the project so that we can view them as different tabs instead. Now let's activate the View Mode Parameters Capacity sections. And in the legend window, you can see the colors corresponding to the capacity of each section, making it easier to spot if there are any anomalies in the model. The same visualization can be done for speed limits. Now, let's look at how to use view modes during a simulation. Go back to the project window and run replication base. Activate the view mode calibration color by turn, and then run the simulation. Zoom in anywhere and observe how the vehicles are colored based on their upcoming turn. Let's go back to the legend window and see what every color means. As you've noticed, the view mode simulated flow is activated automatically when a simulation ends. This view mode displays the flow at each section with color, labels, and width. When you zoom in, the colors and the labels are visible. When you zoom out, the width is added. In the legend window, there are size multipliers that you can use to modify the size of the elements in a view mode. For example, you can increase the size of the labels Or you can also increase the width or decrease them. And you can play around with these values to display the information clearly. Under Object Visibility, you can use these 4 icons to show or hide objects in the network view. For example, you can hide the nodes, or you can also hide section objects such as crosswalks, bus stops, and detectors. You also have the option from the drop-down menu of hiding only select section objects like detectors. Centroid connections and centroids can also be hidden entirely. For centroids, polygons can also be hidden. On the top left corner, you can display the values by time using the back and forward arrows. You can also show the aggregated values by clicking on A. You can also press play to watch how the flow changes every 10 minutes of the simulation from the beginning to end. If you want to modify view modes and view styles directly, you can access them from the Legend window. The Legend icon on the top right opens the View Mode editor. Clicking directly on the view style opens the View Style editor. Before we continue, let's close the simulation and put the view mode back to none. Now, we're going to create new view modes and view styles. Our first example will be a view mode that colors vehicles according to their current speed. Back in the project window, under Data Analysis and View Modes, right-click and select New View Mode. Open the new view mode and name it Vehicle Speed. Click on Add New Style, and a new dialog will appear. Here, set the name to Vehicle Speed Color. In the Objects of Type, select Simulation Vehicle. The style remains as color, and in the attribute, select Current Speed. Click on New, and let's set the first range to be 0 to 20 kilometers per hour. And then click again on New 4 times to maintain the range. And in the very last one, set that as 80 to infinity. Let's use the first color ramp so that the slow vehicles are red while the faster vehicles are green. Click OK for this view style. And then for the view mode, launch an animated simulation for replication base and activate the view mode Vehicle Speed. Press play and zoom into one of the intersections. Observe how the vehicles start becoming more red as they slow down approaching the intersection, and they turn orange or yellow as they speed up, leaving the queues. This looks good at the current scale, but if you zoom out, it becomes difficult to see individual vehicles. We can create a second view style to show vehicles as dots when scale is greater than 1 to 4,000. Go back to the Legend window and open the view mode using the icon. Select Add New Style and rename this Vehicle Speed Spot. In the Objects of Type, select Simulation Vehicle. In Style, select Spot. In Attribute, select ID. Create a new symbol, and in the range, let's define that as 0 to infinity. And on the symbol, in the editor, in the spot type, select Circle. Set size 8. And in the color, set it to Use Objects Color. In the Conditions tab, tick the scale box and set the scale to be between 4,000 and an extremely high value. Click OK on the view style, and notice that now the view mode has two view styles, one for the color and one for the spot. Click OK to save these changes. Now, it's easier to see the speed of the vehicles in the entire network. In this next example, we will create V-modes using diagrams for centroids and public transit vehicles. First, we will create a view mode to display the number of origin and destination trips for each centroid. Back in the project window, under Data Analysis and View Modes, create a new view mode. Open the view mode and name it Total Demands. Click OK and open it again. This way, when you click Add New Style, it's automatically named Total Demands Style 1. In this new view style, set the objects of type to centroids, the style to diagram and then histogram. Set the diagram size to 50, and the format, set it to no decimals, and then check Show Value Label. From the available columns list in the bottom, select Demand Totals and click on the green arrow twice. We want the information both as an origin and as a destination. Set the scale to 2000. Click OK, and another OK for the view mode. And now activate the view mode Total Demands. Now we can see the number of trips generated and attracted to each centroid. Remember that you can also use the size multipliers to dynamically change the size of the diagrams. Another example of using a diagram is to emphasize the movement of public transit vehicles in a simulation. We will create a view mode to visualize them as circles with diameters relative to the vehicle size. So go back to the project window, create a new view mode, open the view mode and name it PT Vehicles. Add new style, and in this new style, in objects of type, select Simulation Transit Vehicle. In the style, select Diagram and leave the second option as circles. In the diagram size, set it to 30 pixels. From the available column list, search for length, add it to the selection, and set the scale to 12. Click OK to save the changes, and then click OK on the PT Vehicles view mode. Now we can activate this new view mode, and let's resume the simulation. Now we're going to use dynamic labels to display attributes that change values during a simulation. Let's zoom into the area of the roundabout and select the detector in the northbound section. Right-click on the detector and select Dynamic Labels. Select New and create a new dynamic label. In the editor dialog, select Count as an attribute, display it for the last generated, and check to show the units. Click OK to save the changes, and let's move the label to the right side of the detector. The values on the label will update according to the detection interval set in scenario outputs to generate, which here is every 10 minutes. Run a replication base Another use for dynamic labels is the Analyzer dynamic label for nodes. Pan to the intersection to the southwest of Camp Nou. Select the intersection right-click, choose Dynamic Labels, create a new Analyzer Dynamic Label. In the dialog, select Count for last generated and set the font size to 2 meters. Click OK, and let's restart the simulation. The results of the turns will be displayed and updated according to the interval set for the statistics in scenario outputs to generate. Now we're going to look at centroid statistics. Open centroid sans and go to the Time Series tab. Let's display the flow, both as an origin and as a destination. We can look at the information in graph mode or in table mode. Here, we see the flow of vehicles generated and attracted to the centroid from the beginning to the end of the simulation. We can also display statistics for specific OD pairs. For example, let's go back to variables, and let's look at the average speed for vehicles that traveled from centroid sans going to B23. In table mode, we can see that the average speed of vehicles traveling from sans to B23 is around 35 kilometers per hour. In this exercise, we're going to look at the statistics of individual lanes within a section. Note, in Aimsun Next, lane 1 is the leftmost lane. Locate section 928 and double-click to open. Go to the Time Series tab, select Variables, and let's display the count and set it for lane 1. Use the plus sign to add 2 more variables, and set that for lane 2, then lane 3. In table mode, we can see how many vehicles traversed each lane. In this exercise, we're going to look at the traffic control statistics such as the red and green time for signals. Locate node 2062 and double-click to open. Select the eastbound through turn, and in the node editor you'll see it highlighted. Select and click on Edit Turn. Now we have a new set of tabs which pertain to the turn currently selected. Click on the Time Series tab, and then Variables. Let's add red percentage. Click on the plus sign, and also add the green percentage. Let's change the colors accordingly. These add up to 100%, so a stacked area graph will be a good format. You can also see the results for the other turns by selecting them on the map. We can create a similar display by using view modes so we can see results for all the turns instead of just one. Let's close this window, and in the project folder, under Data Analysis and View Modes, create a new view mode. Open the new view mode and name it Signal Phases. Add new style and name it Traffic Signals. In Objects of Type, select Turn. In Style, select Diagram, and then Pie. From the available column list, add green percentage and red percentage to the selected columns. Modify the colors to match the signal. Click OK to save the changes for the view style and for the view mode, and then activate the signal view mode. If the diagrams are too small, you can change the size inside the view style or use the size multiplier in the legend window. In this exercise, we will analyze the external and internal trips in the network by creating centroid groupings rather than looking at individual centroids. To create a grouping category, go to the project window. Under Data Analysis, right-click, and create a new grouping category. In the Contents, in List of Objects of Type, select Centroid. Click F2 on your keyboard to quickly rename the new grouping as Grouping Centroids. Under this new grouping, right-click and create a new grouping. Double-click to open and name the first one External. Select the following centroids on the map to add to the selection. Click OK, and do the same thing for the internal centroids, University and Camp Nou. Under Scenarios, open Dynamic Scenario Base and go to the Outputs to Generate tab. Under Statistics, activate Groupings. Click OK to save this change and run Replication Base. Now we have statistics generated for groupings. Close the replication and open the external centroid grouping. Go to the Time Series tab, and in Variables, let's look at the average delay time of vehicles originating and going to external centroids. Here, we see an average delay of about 1 minute for all the external trips. Groupings can also be used to aggregate traffic demand data. Under Demand Data, open Traffic Demand Mat and go to the Summary tab. Select Grouping Centroids for the grouping category, and here we see the total number of external and internal trips for vehicle class car. You can also display it for all the user classes. The same display can be done for OD matrices. Under Demand Data, Centroid Configuration 956, open the car matrix. In the Cells tab, again, let's display the grouping category, Grouping Centroids. And here, we can see the external to external trips, external to internal, and internal to external trips. In this exercise, we will use Print Layout to present results. In the project window, under Data Analysis, create a new print layout and open. The dialog will display a map as seen in 2D view, but you can zoom in, pan around, and resize the map. Activate View Mode Simulated Delay Time. You'll see that the view modes are also reflected inside the map. To add the legend, click on the legend icon. You can drag it to position and resize as needed. Create some space on top of the print layout so that we can add a title. To add a title, click on the text icon and drag the window on top. The text editor is on the right side of the window. Now let's add a time series graph to show the delay time to each destination. Click on the time series icon. This will create a box for a time series, and when you click on it, it'll open a time series viewer. Let's put the windows to the side. In the time series viewer, select all the centroids Select delay time for replication base as a destination, and then add series. Now we can see that we have a time series view inside the print layout. Let's display the information as a chart instead. Now it's easier to see. We can also change the scale from Actions, Auto Scale, to make it more legible. Close the time series viewer, and let's focus on the print layout. You can zoom in to examine it a little closer. And now you can export it as a PDF or as an image. Results of two simulations can be compared using the data comparison tool. In this exercise, we will compare the base and the priority scenarios. The priority scenario has a change in signal timing that gives priority to the tram movement. We already have data for replication base. Now, we need to run replication priority. Let's run a batch simulation. When the simulation finishes, click OK to close the replication, and in the menu bar on top, go to Data Analysis and select Comparison. In the dialog, set the reference to be the replication base and compared to be replication priority. Keep the section and change the variable to delay time. And let's change the colors so that it's red for an increase and green for a decrease in delay time. Keep the compared same as reference. Let's remove the turn comparison. In the bottom right corner, click Compare, which will bring us to the table view of the comparison, showing the absolute and the relative difference. If we set the window aside, we can see that a view mode is automatically created and activated. The green sections experienced a lower delay time in the priority scenario. As expected, the tram sections are green as they were given priority.